square. Yes, complete the square gets more difficult if this number is not divisible by 2. So for example, if it's 3 or 1, of course it's going to be slightly more difficult. What happens if this number, let's say, is 3? Then I have to divide by 3 first of all, and then complete the square. But we don't need to look at that situation. That is last level. But we can look at the situation in which this number is not divisible by 2. Yes, please.
Can you go to the bottom where on the right side of the equal sign, the negative number? I'm just trying to get
on the other side?
Yeah, like just where the numbers are negative. Just
on the right hand side?
Yeah.
Sure. With completing the square? Okay. So then let's say x squared plus x equals -4. Middle coefficient. We are forced to use completing the square. Middle coefficient. Excellent. Divided by 2. 1/2. Square 1/2. 1 squared is 1, 2 squared is 4. 1/2 is 1/2, on 1/2 squared is 1/2 times 1/2. And this is what we have to add to both sides. Okay? Yes, go ahead.
You want us to work in fractions or can we work in decimals?
You can. You have to have a fraction. Sorry about that. Sorry. So one more time, the method of complete the square requires us to identify the middle coefficient. We did. In second step, we are asked to divide this number by 2. We did. In the third step, we are asked to square 1/2. We did. 1/4. So now, can anyone give us the perfect square on the left and the least common denominator on the right? It doesn't have to be the same person. Give me anything. What do we square to get x squared plus x plus 1/4? Say it again. Say it again. I have to have a binomial. Because of this binomial, when I square it, I get a trinomial. If I just put 1/2, when I square 1/2, I'm not going to get 3 terms. But you are close. Very close.
X plus 1.
Exactly. Awesome. First term squared plus 2 times the first times the second plus the second term squared. Awesome. The least common denominator, it's what I have here, right? It must be x plus what I squared to get 1/4. Exactly. You observed. It's nice that you paid attention to that. Awesome. What is the least common denominator here? What do I multiply the top of the first fraction by? Exactly, because it's 1. No, it has 1 in the denominator, so I have to multiply by 4. So -14 plus 1 is -15. Okay, so we have to go back to adding fractions then. That's okay. It's fine. I'm more than willing to go back anywhere. So do we know how to add these fractions? If you say no, I'll show.
Oh, you gotta do common denominator.
I have the common denominator, so this has denominator 1, so it has to be multiplied. I multiply the denominator by 4, as we did on the first problem. I have to multiply the numerator by 4. So -16 and plus 1 is -15. But now if you say review adding fractions, this is serious, and I want to review adding fractions. I mean, I don't have a problem with that. Yes? Okay, very good. So let's finish this one up, and I'll review adding fractions. So at this point, we have the square to take the square root from both. So the left-hand side will be x plus 1/2. The right-hand side is plus or minus. There is a negative inside, so it will be the square root of 15 with I in front divided by 2. And now we move -1/2. I mean, it becomes -1/2. So now I would like to review a few things about adding fractions and subtracting fractions, and I have, yes, I have time. Okay, so yes,
I
go
just
ahead.
have a question about the
Yes.
placement because I remember
Yes.
putting an I after
Yes.
the fraction and they considered that wrong. But then they showed that it just doesn't always have to go in front of the square root, or can it go after the fraction? Because
It's
it
a
was
very-
like different for a couple different
It's a
questions.
very good question. We don't like to put anything behind the square root
Okay.
if we can avoid it. So I times the square root of 15 is the same with the square root of 15 times I, but we prefer I to be in front. Because I
So just
may,
keep it.
here's why. Because when we write by hand, right, especially I'm standing and writing, and there is no excuse, my handwriting is not perfect. But I may, by mistake, extend the square root on top of I
Yeah.
if I put something behind the square root.
And then the computer is different for the
Yes. So now it depends whatever they want you to do.
Okay.
How do you go from the 4 in the denominator to the 2?
Okay, so when we take the square root of a over b, we have to take the square root of a over the square root of b.
Right.
So the square root of 15 is the square root of 15, the square root of 4 is 2.
Got it. Okay.
Concerning fractions, let's say we want to subtract these two fractions. We have to find the least common denominator. It happens, there's so many different situations, but it happens that these two are prime numbers, so they have nothing in common, so the least common denominator must be 14. 2 was multiplied by 7 was multiplied by, so that's the idea. 7 minus 10, negative 3 over 14. Always multiplying and dividing fractions is always easier. But adding and subtracting, especially if they have unlike denominators, then it's slightly more difficult. This is a simple situation because I only had to multiply those two prime numbers. But now if I have, for example, let's say 4, as we had, or negative 4 minus plus 1/4, then we consider this over 1. 1 and 4, pretty much similar situation. The least common denominator is 4. 1 was multiplied by 4. 4 was multiplied by. So negative 4 times 4 would be negative 16, and then plus 1. So I'm hoping that moving forward, these kind of arithmetic situations, arithmetic situation, you know, are not going to prevent us from moving faster. But if you encounter something, please bring it to class or ask me. Yes, please, Kayla.
When you're putting that,
Yes.
you had put the 4. Yeah. When you put that little like swoop sign,
It's not.
that means you're multiplying, right?
Yes, exactly. So this is kind of, it's not a fraction line. This is like a reminder. It tells me, look, you multiply the denominator by 4. Remember, you have to multiply the numerator by 4.
I
Otherwise,
just kept thinking it was a division sign. I kept it.
yeah, that's why I wanted to clarify that. Very good question. No, so this is just a reminder. You don't have to use it. You can, when I showed this to other students, they wrote it like this. They prefer to write like that. Instead that, you know.
That's how.
Yeah, just make up your own, whatever works for you. Okay? So I saw some of my students do this instead of just, as you say, that swish. Exactly. I agree. Okay. Do we need more examples of this, or can we finish up with the quadratic formula one more time? Quadratic formula. Okay, so here's an example with the quadratic formula. So let's say 3x squared minus 2x plus 4 equals 0. This has to be the setup. The polynomial has to be on this side and 0 on the other side. The quadratic polynomial. Quadratic. If you do not have the quadratic polynomial in descending order, the equal symbol and 0, you cannot use the quadratic formula. Okay? So then we have x equals negative b, negative 2, that's 2, plus or minus b squared, what do I write here?
-2.
Squared, which is, if I see a negative here without parentheses, or you start under the square root with a negative number, I cannot give credit.
4.
Perfect. Minus 4ac, 3 times 4, over 2 times a. Excellent. This, however, you will not be able to put in the graphing calculator, but you will be able to simplify the inside. Okay, so from here I have x equals 2 plus or minus the square root of. So 12 times 4, but I'd rather factor out a 4. Let me explain why. If I'm asked to present an exact answer, factoring out a 4 will be much easier than not factoring out and then still have to factor it at the end. So I factor out 4 from here. 4 times 1 is this. 3 times 4 is 12. So 4 times 12 is 4 times 3 times 4. But this enables me to take the square root from 4. And this is negative 11. So then x will be 2 plus or minus 2i, the square root of 11, divided by 6. Let's do this one more time. The square root of 4 is this piece. This quantity is the negative 11. But the square root of negative 11 is I, the square root of 11. Now we separate. 2 over 6 is 1/3, plus or minus I, the square root of 11 over 3. Any questions? Yes, please. Go ahead.
I need you to go back. Okay, so you said 3 times 4 is 12.
Yes.
Where's the 1 coming from?
This one?
Yeah.
So when I have two terms and I pull out a factor, 4 times 1 is 4. 4 times 12 is this. So I have two terms and I factor out 4. If I don't put the 1, it means that I started with one term, but I didn't. I started with two terms. So 4 times 1 is 4, and 4 times negative 12 is this number. What about this? If you factor out x, what is left? Still 1 minus 2x. It's the same idea. I had 4 minus 4 times 3 times 4. So I factor out the same thing like x. I factor out 4 and I have 1 minus 12. This is 12. Same idea, exactly like this. I factor out x and I got 1 minus 2x. I factor out 4 and I got 1 minus 12.
So if we were to just do the multiplication,
Of course,
4 times 3,
you will get the same answer, but you're going to get a bigger number and then you still have to factor out 4 out of it. That's the thing. When you multiply, what do you get?
52.
Right. So you get negative 52. Careful. Right. I agree. So when you get negative 52, you still have to say the square root of negative 1 times 4 times 11. You have no choice. It's not times 11. So it was 52.
Well, that I just typed in the whole thing.
So it's 4 minus 4 times 12. 4 minus 4 times 12 is 44. It's negative 44. It's not 52.
Oh, I was. Okay.
It has to be the same number. I mean, I can, yes,
So in the quadratic formula, the
Yes.
square root of b squared
yes.
is negative 4, not minus 4. AC.
You're talking about here.
Yeah.
So it's b squared minus 4 times a times c.
Yeah, so then I thought it was going to be the square root of 4, then it would be the minus, because I was doing that way, the 52. So that's I'm like, why are we taking the 4 out? If we supposed to subtract?
From here.
Yeah.
Well, you're talking about this quantity.
Yeah, why are we factoring it out if it's subtraction?
So here you got negative 44. What did you get with 4 minus 4 times 3 times 4?
So like, okay, so the way I learned the quadratic formula was that you just do the 4 times 3 times 4. Okay, and then that's the negative 52. So then it would be 4 minus 52 over the 6.
So do you have the square root of 4 minus 4 times 3 times 4? Do you have
So
this?
then it would be 48.
So one more time. So do you have 4 minus 4 times 3 times 4? Is this correct?
Yeah, but you're saying factor out. I'm confused why we're factoring if we're.
You don't have to factor it. Forget about factoring. So what do you get?
So you just show it different ways so everything can get the same answer.
Because you still, of course. So what do you get with 4 minus 4 times 3 times 4? What is this number? What did you get for this number?
Negative 44.
Correct.
Negative 48.
No, that's not possible. Do it again.
I was just confused because I put in the whole 2 times 2 squared plus 4.
Why is it plus? Why is this plus? The formula has minus. I can't change that into a plus. That cannot be changed into a plus. So it's negative b plus or minus b squared minus 4ac. Okay, my final question here. What is this number? Ladies and gentlemen.
Negative 44.
Okay, so if it's negative 44, then you have to break it up into negative 1 times 4 times 11. And you will end up having 2i the square of 11. 2i the square of 11. No matter how you do it the way you want it. You still get 2i the square of 11. So after you get 2i the square of 11, no matter how you get it, it doesn't matter. Any method works. I accept it. Fine. Then you still have to separate into 2 fractions and get this. Yes, please.
I think between each step